Hello advanced math students, welcome to the walkthrough video of your homework review. I thought that we would try to do this in stages here. So the first section you're going to see is me just going over question number 6 in this function inverses review packet. Seeing as that's going to be a potential bonus type question, I thought it couldn't hurt for you guys to hear a walkthrough if you want to. So if you want, you can skip ahead to the next title in the video if you're not interested in the bonus. The next title you'll be looking for is Finding Inverses 9 through 16. But if you're interested in the bonus, let's take a look at it right now. Okay, so I'm going to zoom in here so we can see this problem a lot better. I did not follow my own instructions to you guys of trying not to cram all this work in the very tiny workroom that the CUDA people allowed us for this particular worksheet. So follow along with me as best you can. Again, I'm on number 6 because this is going to be a bonus level type question. So we have two functions. We have f of n and we have g of n. And remember, the purpose of using function composition to figure out if two things are inverses is that one function is going to go inside of another. So the first composition we want to do is f of g of n, or fog, as some of you are fond of saying. But what that means is this entire function g here is going to take the place of the input variable for f, which is n. So that's why you see this whole expression 4 plus cube root of 4 times n all over 2 is now gotten substituted in here where n would normally be in my f function, okay? And then minus 2, and then all of that in parentheses cubed. So this is a little bit tricky here. We have to do some simplification, but I think you're going to see how everything kind of just falls apart in a good way, okay? So if we look at and try to get a common denominator for the minus 2, of course that's the same as minus 4 halves. So we're going to put that minus 4 up in the numerator along with the first two terms here, and then basically everything is all over 2. So now look what's happening with our 4's is that they're going to cancel right out, so that's lovely. And then when we cube something that is got two parts to it, it's a fraction, so we've got our cube outside and we've got a numerator and a denominator, we need to make sure that we are cubing the cube root, and as you know that is going to, this cube here, and the cube root, just like squaring a square root, it's going to undo it and just leave you with the expression underneath, which is 4n. Then of course we're going to cube the denominator of 2 itself, because we're going to apply these exponents before we do the multiply by 2 in the front. So again, the cube and the cube root undo each other, we just have 4n, and the cube of 2 is 8, so we have that there. And then if we reduce, of course we're just going to have 4n over 4, and that is all going to simplify to just n. So we have made it work for one direction, which is fog. Now we need to verify that with the other direction, g of f of n next, or goff, as some of you have been fond of saying, that if we compose these two functions in the other direction, we're still going to land with just n. So again, let's walk through the steps there. The expression that f is equal to becomes my input underneath the radical here in the g, because that's the only place we see our n in the g function. So first off, we have g of this whole expression, and then you can see me substituting that right in there for our n variable. And if we simplify the 4 and the 2 on the outside, that's just 8. And then we are taking the cube root, again, of something cubed. So the cube root of 8 is 2, and the cube root of something cubed is just that expression, n minus 2. We still need to distribute this 2 throughout the parenthesis, so that's going to give us 4 plus 2n minus 4, and then of course all of that's over 2. So look what happens again. Those constants are going to cancel right out for me. Isn't that nice? And then 2n over 2 is back to just a single variable, the input variable n. So since both of these come out to be just n, then we can say yes, they are inverses of each other. So that's my final answer there, is a yes, and we have done the algebraic verification. All right, let's move on next to our finding inverses section. So here we are in our finding inverses section, which starts with number 9. And if you recall, the two major steps that we talked about here are number 1, switch the places of x and y in the original function, and then once they're switched, try to isolate y. So in number 9, as we see here, we are looking at h of x, remember, is the same thing as y, so write that as y to begin with. Then we have the cube root of x, all minus 3. If we trade places with x and y, just changing places in the expression or in the equation, now our goal is to get this y underneath the radical out. So we got to peel away the layers from the outside of that right-hand side of the equation, step by step down to the y, okay? So the first thing we're going to do, of course, is to add 3 to both sides to get rid of the 3 on that side. And then as we get to the next step, we're going to cube to get rid of the cube root. And so we are left with x plus 3 all cubed is equal to y. And then remember, anytime we have the inverse function, the notation is h inverse of x, and we write that as h with a -1 almost as an exponent or a superscript there, h -1x, but we don't say -1, we say h inverse, okay, so or the inverse of h, okay. Let's look at number 10. Number 10, we are going to again start by plugging y, substituting y in for g of x, and then we're trading the places of these two variables. So once we are taking x equals 1 over y minus 2, first step would be to move this -2 over by adding. And then notice what I did here. 1 over y, I'm not really interested in 1 over y, I'm interested in y, or y over 1. So it's a very simple process of just creating a fraction on the left-hand side for x plus 2, all being over 1, and then simply flipping that proportion on its head. So instead of 1 over y, we now have y over 1, and that is equal to 1 over x plus 2. And so that's my g inverse x. Let's look at number 11 next. Number 11, we have another cube to begin with here. So I hope you can kind of anticipate that we're going to be undoing it with a cube root somewhere in the expression. First again, substitute y in place of h of x, then trade the places of x and y, and now we need to get this y alone. So subtract off the positive 3 from both sides. We get x minus 3. Then we're going to get y cubed alone first. As we're looking at layers to get to y, we first need to get that term that y is in alone, and then we need to get just the exponential part that y is a part of. The 2 is being multiplied, so I'm going to divide by it. Once my y cubed is alone, and only at this point, you guys, only once your cubed is isolated, can you go ahead and take the cube root. But now it's going to be a more complicated cube root, but that's okay. It's the cube root of this whole entire rational expression, x minus 3 all over 2. And that is equal to y now finally, and we can put the label h inverse of x with it. Next problem, number 12. And in number 12, we have just a very simple linear function. So this one should go pretty quickly. If we change the places of x and y, once y is in the place of g of x, change those places, and just do the algebra. Subtract the 1 off of both sides to get rid of the plus 1, and then of course divide by negative 4. You can go ahead and leave it like this if you want to, or if you'd rather put it in slope-intercept form, which is more what we're going to see in our next section as we're graphing. That's probably most helpful. So you want to think of dividing that negative 4 into both terms, the x and the negative 1, which is negative 1/4 x and a positive 1/4, and that is finally g inverse of x. With number 13 to begin with here, we're still doing the process of finding the inverse by using just algebra. And so g of x is equal to this rational expression here. Again, replacing y in place of g of x. We're going to trade the places of your variables, and then layer by layer try to get to this variable y alone. So first off, we have the whole rational expression being divided by 2, so we're going to reverse that by multiplying both sides by 2. And I didn't write these steps in, but if you guys want to see it, there it is. That's where, of course, my 2's are going to cancel out. So I have 7y plus 18 now that I need to get one step closer to y. I'm going to subtract my 18. And once I subtracted my 18, now I just have 7y alone, and of course we're going to divide, so that's where you see me going up here. We're dividing both sides by 7, and we're left with the expression that you see in the highlighted answer. For 14, another pretty basic linear expression there. We would start with y equals x plus 3 in place of f of x, the y. Switch the places of x and y and simply solve for y. That's a pretty quick one. So y is x minus 3, or f inverse of x is x minus 3. Moving over to number 15, another linear function. Again, pretty simple to solve for. We're going to plug in substitute our y for our f of x, trade the places of x and y, and notice that's trading just the places. Notice the sign stays put. It's on the right-hand side. It stays on the right-hand side once the variables change. Then we're going to subtract the 3. And now we have x minus 3 still is equal to negative y. So divide by negative 1 all the way across, and we get negative x plus 3 equals y, or f inverse. Finally, in this section, let's look at number 16. And for number 16, we have again a very basic expression of just a linear equation to begin with. So y equals 4x, trade the places of x and y, solve for y. It's just a simple divide by 4 here. So x over 4 equals your f inverse in this case. All right, that takes us to the end of the section where we're finding those inverses algebraically. That is a skill you guys are going to need to know for your test. The next section is where we're talking about graphing, 17 through 20. So let's take a look at that next. Okay, so for 17 through 20, I'm going to zoom out a little bit here so we can see the full graph as we illustrate. I believe we did 17 in class together. This is a linear function, and so we're going to take a look at two important points on any linear function. which of course is my intercept point of 0, -1, because that's my b value. If I think of mx plus b, this is actually b plus mx, the way that it's written with the constant term first. But -1 is my y-intercept, so the point is 0, -1. When I take the inverse and I'm trying to graph that, it's very simply just flip the x and y, just like I was doing algebraically in the previous section, only now it's actually trade the places of the x and y coordinates. So where x was 0 and f of x or y was -1, now x is -1 and f inverse or y is 0. So you can plot that point, -1, 0, and you see that there. And then we need another point on the original function. So what I would suggest to you is if we have our slope of -1/5, then from my original intercept point, I would want to draw my slope triangle by running 5 and rising -1 to get to another grid intersection point, if you will, and that's how we found, or I found, the point 5, -2 to start with on the original function. And we're going to flip that on its head. It's going to be -2, 5 for the second point of our inverse. On each of these graphs that you guys are going to see, you're going to see me having the original graph highlighted in green, or I guess it's more like yellow on your screen, but that's what you want to see as your original function. Then also, I just backed this up with solving to actually find the inverse, which is what we were doing in the last section. So here's y equals -1 minus 1/5 x. If we want to solve, trade places of x and y again and solve for y, the steps we would take would be to move that -1 by adding, and then to multiply by the reciprocal of -1/5, which is just -5 to get y alone, and -5x minus 5. If you take a look at the equation and then compare that to the graph, we would have an intercept of -5, which, if this is my inverse, follow me down here, there's my inverse intercept, okay, which is -5. And then does that have a slope of -5 over 1? Yes, it absolutely does. We don't have enough space to go back and to the right and down, but we certainly do have enough space to go to the left and up. And notice it's over 1 and up 1, 2, 3, 4, 5. So that's how all of those pieces tie together, the algebra, the graphing, all of that for the inverse for number 17. Let's look at 18 next. So 18 is a little different just because it does start out as a rational function or an inverse variation, and we know from the original equation that if this is my h value, remember, in the denominator, then we are shifting to the right one. So that's why you see here, and I'm not going to draw it because there's a lot of lines on this graph, but I'm just going to trace it with my pointer. This vertical line right here is the Gandalf, or the asymptote, vertical asymptote. And the original, there's no plus anything outside the equation, so we would have our original y equals 0 or x-axis for our horizontal asymptote. So that's what you see me summarizing here. Vertical asymptote is the equation x equals 1, and the horizontal asymptote is the equation y equals 0. So just like the last example where we traded the places of the x and y coordinate, now we're going to trade the places of the x and y letters, okay? So x equals 1, that line, transfers from a vertical asymptote to y equals 1 as a horizontal asymptote on the inverse. The same thing is true here for my original horizontal asymptote of y equals 0. When I'm talking about the inverse, I'm trading the places of x and y, and so that is the line x equals 0, which has become a vertical asymptote. So that's what you see described with the non-highlighted graph, and if you look at it, here's my x equals 0, my vertical asymptote, and here is my y equals 1, my horizontal asymptote. And then again, you can see the process I went through here algebraically just to verify what the inverse was. If we're going to go ahead and start with y equals 1 over x minus 1, as we do here, trade the places of those variables. And then again, if we're interested in y, which is in the denominator, probably makes sense to take this proportion, which we make into a proportion by putting that denominator there of over 1, and to flip it on its head, okay? So that's y minus 1 over 1 is equal now to 1 over x. We just completely take the reciprocal of both sides of the equation. That is a legal algebraic operation. And then once we have y minus 1 now back up in the numerator, we can add that 1 to the other side. And hopefully you can see from this inverse that yes, indeed, we have moved up 1 because that's my k value, and we're not moving left or right at all because there's no h going on in that denominator of this inverse variation function. Okay, let's look at another type of function in number 19. Okay, in number 19 we have a cubic function. We have negative 2x cubed plus 1, and this is, of course, this function right here that is highlighted as your original. I did say skip this, but if you want to kind of look at my grid of points, or my table of points, what I did was basically 2 points, one on either side of the kind of the center of that little swoop there, and then of course take those points and turn them on their heads into the inverse. I'm not going to go through this one. This one would not be one that I would expect for you guys to be able to graph the inverse of, so we're going to skip it, but there's the work in case you want to pause and kind of walk through the steps. You should, I think it's easy enough to follow, but again, it's not one of a type that you're going to see on your test, so we'll skip it for now. Let's go to number 20 finally here in our homework walkthrough review video. Number 20 is another rational function. If I were to take this original function here, it is actually a linear function because the variable, there's not a variable in the denominator, so 3 divides nicely into each one of these terms. So we get a negative 1/3 x and a minus 5/3. So this is a linear function to begin with. But because my intercept is a fraction, what I chose to do was to just plot some points instead, where I knew that I would be coming out with integer answers. So if I'm dividing something by 3, I figured what's a good number to divide by 3? Well, multiples of 3 are like 3, 6, 9. So I started off with, if I put a 1 in for x, that would give me a negative 6 in the numerator, and that divided by 3 is negative 2. So that's my first grid point on the original graph that you can see. And then of course we have a negative 1/3 for our slope. So there's my slope triangle, run 3, rise negative 1 to get to my next grid point, which is 4, negative 3. Remember what we did in number 17? This is similar. We find 2 points, and then we trade the places of the x and the y coordinates to find the other equation. And you can see that that's been done here. I guess I forgot to put a little grid point at negative 3, 4, but let's do that right now. Okay, and let's go ahead and do the algebra of figuring out the actual inverse. So we're going to start with y here. So y equals negative x minus 5 all over 3. Trade the places of x and y and solve for y. We're going to reverse the division of 3 by multiplying both sides by 3 to begin with. Then we're going to move our minus 5 by adding 5 to both sides. And then once you have that all equal, that's still to negative y. So divide everything through by a negative 1. We get negative 3x minus 5. Let's double check the graph that we came up with when we flip-flopped the points. If this is my intercept, -5, we can see, yes, indeed, that is my intercept. And again, I don't have enough grid space to go over 1, down 3 that direction, but I can go left and I can go up. And that slope triangle is definitely showing you a slope of -3, so you're good to go. Okay, I hope that this video has been helpful for you guys to hear how I would explain through these problems. Again, remember this is always available to you and you can slow it down, review it, but I hope that's been helpful. If you have any remaining questions, please make sure that on your Google Classroom page underneath this video's posting, you are adding comments there so that I can kind of give an idea of how to help you before the test on Tuesday. And also, if you have questions that you're posting right now in class, then your classmates can help pitch in and answer those questions for you too without it becoming too distracting noise level wise for everyone in the room. Thanks, you guys. I'll see you guys on Tuesday for your test.